Hi guys, this is Maths for Everyone. Now today I'm going to do sine rule, but before I do sine rule, I want to do trigonometric equations. Okay, here we go. I've written the question here. I solve each trigonometric equation, giving all possible acute and obtuse solutions correct to the nearest degree. Now here it says acute and obtuse angles. Now what does that mean? Acute angle is what? 0 to 90, and obtuse is a 90 to 180. Now here it's in between, so it's in the first quadrant, and this is the second quadrant. That's what we are looking at. Okay, let's have a look. So calculator ready, guys, because we are looking for the angles here. Angle, we need to have what? Shift sine or shift cos or shift tan. Okay, so theta equals sine inverse, because when we move the sine to the other side, it becomes sine inverse, and that is 0.7538. And you put that in your calculator, you will get something like 48.9206 ... Okay, so now you've got to use, so maybe I put here shift in your calculator, and then sine, and then you equals, and then press this hour, a degree, minute, and second button. Okay, so when you, okay, like move that one, can you see it? Yeah, so when you do that, you will get 48 degrees, something like that. Okay, so I'm going to do it to the nearest degree, so I'm going to go 49 degrees. Okay, now that's our acute angle, guys. Acute angle. Is that all possible? Acute, that's in the first quadrant. Now obtuse in the second quadrant. Second quadrant will be, what's the formula, guys? 180 take away theta, which is 49. Now theta is the principal angle, which is always acute angle from first quadrant. Now, so it'll be 180 degrees, take away 49 degrees, that will give you 131 degrees. So my answer to this question is 49 degrees and 131. So the answer is, therefore, theta is 49 or 131 degrees. Okay, it could be in the first quadrant, it could be in the second quadrant. To get the positive sine theta. Remember, the positive sine theta is what? All station to central, all station to central, and the first quadrant and second quadrant, sine is positive. Now here, tan theta equals 0.3. It's a positive, so before we start anything, all station to central, which quadrants has a tangent is positive? First and the third. First and the third. Now, let's think about this logically, guys. Third is not obtuse, okay? First, acute, yeah, fair enough. Second quadrant is obtuse, okay? Now, third is, when it goes to third, it's a reflex. So what's going to happen? We are not going to have two solutions, one acute, one obtuse, because there isn't any obtuse angle that is going to satisfy this. What is this one? As 10 is a positive, okay? So, you know what I'm talking about here. So theta equals 10 inverse 0.3. If I do that, I will get something like 17 degrees. If you do that in your calculator, 17 degrees. Now, don't put 180 take away 17, because there's no existence, because it's a positive, okay? So only solution is 17 degrees, acute angle only, because tan theta is 0.3, has to be positive, which is first and third quadrant, and we cannot use third quadrant because it's not obtuse, it's a reflex. Okay, so that's only one solution. Okay, be careful with that one. Now I'm going to clean this. Look at this, I can clean the board beautifully. If you know what I'm talking about, the last video I tried to clean my board, it was disaster. So now I found the right combination with the rubber. So here we go, let's have a look at this. Now sine rule, guys, sine rule. Before we do sine rule, let's have a look. Sine rule, cosine rule, all that we're going to do is second part of trigonometry, which means non-right angle triangle. All these rules that we are about to use, we are going to have no right angle triangle. Okay? So if I sketch triangle something like this, A, B, C, and then I'm going to actually label A, little c, little b as a side of the triangle. Okay, now how are we going to find, if we want to find side, or even the angle, like angle A, angle B, angle C, how are we going to find it? We can't use SOHCAHTOA anymore because it's not a right angle triangle. So how are we going to do it? I don't know. So here we go, sine rule and cosine rule. It's going to help us to find angle and the side. So first thing first, I'm going to create perpendicular line, which will be my height of this triangle. Okay, so I'm going to find angle C, and then using angle B, and it's a sine rule, so I'm going to use this triangle. I'm going to find sine C equals, what's sine C? It's a right angle triangle now, so it's SOHCAHTOA. You can use SOHCAHTOA. If you use SOHCAHTOA, you will get H over B, okay, for this triangle. Now this triangle, I'm going to use angle B, so it'll be sine B equals H over C, okay, and then I'm going to make it in terms of H, so here H equals B sine C, okay. What I did was I just times by B, okay, on here, and I'm going to times by C on the both side. I will get H equals C sine B. Now, from the simultaneous equations, you know, they're both HH, so substitution, I'm going to make this one into the same as this one. So therefore, I'm going to have B sine C equals C sine B. Yeah, because they're all in the same term, right? That's all right. Now, I'm going to rub this one off because I don't think you can see it. So what I'm going to put it in here again is sine C equals C sine B. Now, what I'm going to do here is I'm going to divide it by, as you can see, you probably saw the sine rule and cosine rule is like this. Sine C over C equals sine B over B. And then there was another one, is sine A over A. Really, you just need to have to know it's just 2, okay, not 3. So anyway, we got this, and I'm going to try to make it look like this. So what I'm going to do is I'm going to divide it by B, okay, divide by B. So I'm going to go B, B. So I'll cancel that, sine C equals C, sine B over B. Alright, so what's happening here is I'm going to divide it by C again, so I can get rid of this C. So it'll be sine C over C equals, if I divide it by C here, it will cancel, so sine B over B, and that's what I've got. Okay, that's our formula for sine rule. Now, this is for looking for an angle, okay? Anything on the top is what we're looking for. Now, if I want to find, that's angle. If I want to find for side, I will go with C over sine C equals B over sine B. So, this formula is for looking for angle. This is for side. But just remember, whatever the question asks you to find angle, you just put the unknown angle on the top. And if the question asks you to find the side, just put the unknown side on the top of the fraction. So make it into numerator. That's all. That's all. Okay, so let's have a look at the question. Yes, I think we are ready for question. So first question I'm going to do is, let's have a look. Now you can see it's not a right angle triangle, guys. No more right angle triangle here on. So it'll be 10 centimeters, and that's X. I don't know what it is. And here is a 70 degrees, and that's a 65 degrees. Okay? So how am I going to find the X? You can't use a soccer toy, remember? This is not a right angle triangle, so we have to use the sine rule. Sine rule says here, but before we do it, you can see that side C, the angle C is with side C, angle B is with B. So they are opposite together. Angle and the side opposite together. So I'm going to just make it into opposite, make sure they're opposite to each other. So this angle is opposite to this side, this angle is, so I can use sine rule. If it doesn't happen like this, you cannot use a sine rule. Now this one, I can use a sine rule. So I'm going to put, now remember, I'm going to have to put the unknown side on the top. So X over sine 70 degrees equals, you have to keep it in the same order because it's a ratio, guys. So if you put the side on the top and the angle bottom, you've got to do the same thing on the second part. So I'm going to put 10 centimeters on the top and then sine 65 degrees. Okay? So that's what's going to happen. Now, and then we're going to solve it and just times by sine 70 degrees on both sides because I want to make X the subject. That's what we're looking for. We're looking for what is the X side. Okay? So, X, when I times by sine 70 here, sine 70, it cancels out. X equals 10 over sine 65 times sine 70. Okay? And put that in a calculator. What do you get? You get 10.368 ... and I'm going to make it into 2 decimal place. So it'll be 10.37. What's a unit? Centimeters. Because it's a side. Okay? That's not too bad. Oh, hopefully you could see it. I made it into 2.37 centimeters. There you go. You can see it now. Alright, so that wasn't too bad. Now, what about if I have to find the angles, guys? How about if I have to find the angles? So I'm going to draw another triangle, non-right angle triangle, to find angle. So upside down one this time. Make it 70 and make it into theta. We don't know. 20 meters. And I'm going to make it into 30 meters here. Again, this is a non-right angle triangle, and I'm going to check whether I can use sine rule or not. So I'm going to go opposite, opposite. Yep, it looks good. Opposite, opposite. Yes, I can use my sine rule. So this time I've got my angle on the top because angle is unknown. So I'm going to go sine. Don't forget put sine theta. Don't put just a theta over. Okay, is 20 equals sine 70 over 30. Okay, so that's what's going to happen. So, and then I want to make a sine theta subject, so I'm just going to go times by 20 on both sides here. So it's going to be sine theta equals 20 times sine 70 degrees over 30. Now, whenever you're looking for an angle, you've got to use a shift, sine, shift, cos, shift 10. So here, theta equals sine inverse the whole thing. I don't really need to do that. Okay, so put that in your calculator. What do we get? I will get 38 degrees and 47 minutes because I'm looking for theta to the nearest minute. Nearest minute. Okay, so that's my angle right there. Excellent. So that's not too bad. Now, we are going to do applied questions using Sine Rule. Applied questions. So it's going to be a little bit difficult. You have to listen carefully because I'm not going to write it down, the question. So listen carefully. Ready? Two people are standing apart 2.5 kilometers each other. So 2.5 kilometers apart. Okay? I'll just write them in. Two people also see the same boat. Okay, so they're standing apart 2.5 and then see one boat here. The boat is on a bearing of 0.72 degrees from person A and 120 degrees. So person A 0.72 degrees and person B 120 degrees from person B. Okay, calculate the distance, which is kilometers distance. I'm going to X kilometers in what? One decimal place. We'll say one decimal place. From person B. From person B. Okay, so this is we read the question, we understand the question, and then we collect all the information. Now we're going to solve it. How are we going to solve it? I need to draw. I need to sketch something. So here we go. Bearings. Okay, so true north. That's a north. That's a south, west, and east. Okay, so person A. I'm going to put A here. Person A is here, and the boat is 0.72. That's 72 degrees. So boat is here. Okay, so the boat is here, and then person B is in 120 degree bearing of time. So I'm gonna go, B is here. They're both standing on a straight line, and then distance between A and B is 2.5 kilometers, and I'm gonna have to sketch another bearings here, and then 120 from here to here, 120 degrees. Are we okay with this? Yeah? So I've got this non-right angle triangle right now. And I need to find the distance, distance of the boat from person B. So that's my X right there. Okay? So let's have a look. I'm just looking at this triangle. I'm going to put this here. Okay, so hang on a minute, before I do it, whether I can use a sine rule or not. So this is okay. I've got matched up with the side and angle. Now this might be a problem because we don't know what this angle is. So we need to find this angle. So what I'm going to do is I'm going to find this angle first. So what's this angle, guys? It'll be 180 take away 120, 60 degrees. Okay, so that's a 60 degrees. What's the angle sum of triangle? 180. So this angle will be 180 take away, 60 take away, and 72. You will get 48. Use your calculator if you're not sure about it. So that's my 48. Now I've got the pair, okay? I've got the two sets of pairs here that we can actually work with sine rule. So I'm going to use X on the top, sine 72 degrees equals 2.5 kilometers over sine 48. Now, do you understand this, what I've done? If you don't, listen, watch more than once, please. Now, I'm going to times by sine 72 on both sides. I will get X equals 2.5 times sine 72 degrees over sine 48 degrees. And if you put in a calculator, you will get 3.199 something, something, something. Okay? So, therefore, my X equals 3.2 kilometers in one decimal place. Okay? That's what it is. Now, that was a little bit tricky, but I'm sure you can do it well. Just listen carefully for the questions and have a go at it by yourself and then sketch it. Number one is sketching it correctly. Okay? Good luck. See ya.